In this video, we'll discuss how to find the probabilities for z-scores. I'm going to make a second video which will discuss how to find the probabilities for things that aren't z-scores, but this video will focus solely on z-scores. So for every normal distribution, we're going to draw these curves. And when we draw these curves, we're going to find the areas that are associated with the shading of the curve that we're going to do. In order to do that, we're going to use a function in our calculator called normal CDF. Let's go ahead and locate that function. If you press the second key, and again hit bars, you see your first two functions are normal PDF and CDF. For the binomial, we use the PDF and the CDF because that was the discrete distribution. The normal function is a continuous distribution, which means it only calculates values up to and below. So for this particular function, we're only going to use the CDF. We always use the CDF and never the PDF. So we'll go here to the PDF, and if you click enter on the CDF, the CDF wants this for the syntax. Down here you can see it says it wants normal CDF, it wants the lower bound and upper bound, a mean, and a standard deviation. Since we're focusing on z-scores, our mean for the time being will always be 0, and our standard deviation will always be 1. That leaves us with determining the lower and the upper bounds. Because the normal curve goes on forever in both directions towards negative infinity and positive infinity, the calculator wants to integrate with bounds. We need to give the calculator bounds. So we're going to make up values for negative infinity, which is a really small number, and positive infinity, which is a really big number. The bounds for negative infinity. So we're going to draw a curve, and we're going to look at this curve for negative infinity. When we're looking at negative infinity, we're looking at the left-hand side of the curve. We're going to give the value negative 99999. We just want to put a bunch of 9s back here. You can put 5 9s, you can put 20 9s. Just put a whole bunch of 9s in the back. And then for positive infinity, we're going to draw a curve again. And on positive infinity, when we talk about that, we're going to put a bunch of positive 99999. However many you want to, just at least put 5 for the time being. So once we have that done, we'll actually find the area for z-scores. And we're going to talk about 3 different types of curves. The first curve is what is known as a lower curve. And when you find a lower curve, you're going to draw your curve. The problem's going to tell you to find the area that's associated with that is either at or below that particular z-score that you find. So when we type in our calculator, it'll be normal CDF, and we're going to go negative. We should use the negative key and not the minus key. 99999. So put at least 5, or you can put however many you want to. Right here I have 6. Then you're going to put a comma, and some of you won't see it like this depending on the software, the calculator you have. It'll say lower. If it says lower, each of the negative 99, that's what it's approximating, negative 9999. If it says upper, each of the positive 99, again, it's approximating that positive infinity value. But it'll always ask you for an upper, a lower, or mean, and a standard deviation. Remember, our mean here is going to be the value 0, and our standard deviation will be 1. Well, we want to find the probability associated with a z-score of 1.28. So what we do first, we normally draw the curve. We're going to draw this curve here. And we're going to set the mean. We're going to write the mean at 0. And then we're going to locate 1.28 with respect to 0. Well, 1.28 is in the right hand of 0. So what we're going to do is, since it's less than, we're shading less than 1.28. So we'll shade the curve 1.28. And now we'll go to the calculator. And again, we can see from this curve that the lower bound is down here at negative 99999. And it's being stopped at what value? Well, it's stopped at 1.28, so that's the upper bound. So we're typing the upper bound now as 1.28, comma, with the mean at 0 and the standard deviation at 1. This right here is going to give me the probability that's associated with a z-score of 1.28, anything below it, and that's equal to 0.8997. So this is for a lower curve. Let's look at an upper curve. For an upper curve, it finds the area above a particular z-score. And again, here's how it changes. Let's look at find the probability that z is greater than or equal to 1.28. So again, we draw the curve, label the mean at 0 this time. Where is 1.28 with respect to 0? It's on the right-hand side. So we'll draw on the right-hand side. And this time we're going to shade, since it's above 1.28, we shade to the right. Go to our calculator now. Second, bars, normal CDF. This time my lower bound, looking at the picture, the lower bound is at where? 1.28. So I'm going to start it at 1.28. Nothing's lower than that on this curve. Comma. My upper bound goes to positive infinity. Again, my calculator can't handle that, so I put a whole bunch of 9s in there for it. However many you want to. Comma. Mean is at 0. Standard deviation is at 1. And we get 0.10027. And notice that this is the complement of the last problem. That's because you're shading to the other side of the problem. If you add up those two values, you're going to get 1, which is the probability underneath the entire curve. Let's look at the last type of curve, which is a between curve. And let's find the area between two z-scores. And so now when we do this, I want to find the probability between negative 1.28 and positive 1.28. So I'm going to draw a curve. On this curve, I'm going to label the mean at 0. Where does negative 1.28 fall at? Well, it falls to the left of 0. Where does positive 1.28 fall at? It falls to the right of 0. I'm shading in between here. I want to find the area in between. So now when I look at this, again, I'm going to do normal CDF. Second, bars, normal CDF. The lower bound this time, where's the curve being stopped at? Well, it stopped at the negative z-score, negative 1.28. And it goes up to what value? The positive z-score, which is 1.28. The mean is 0. And the standard deviation is 1. We press enter, and we get this value, 0.799 or about 0.80.